Hello, and today we're going to talk about the Search for Solutions project. Our group is doing stratospheric sulfate aerosols. I'm Chris,
I'm Tony, and
and I'll let Eliana help create the slides.
so aerosols, what are they? Aerosols are tiny particles suspended in the atmosphere, can come from natural or man-made sources. The direct effect of them, they scatter sunlight back into space, creating a cooling effect. The indirect effect, they modify the size of cloud particles, changing how clouds reflect and absorb sunlight.
So what are stratospheric sulfate aerosols? Well, sulfate aerosols can be particles of sulfate, which are also known as SO4, where they're suspended in the atmosphere and they can bond with the different particles in the sky. And also, they're an aspect of solar radiation management that focuses on geoengineering. They do not reduce the amount of greenhouse gases in the atmosphere, however.
The impact on the world. Injecting sulfate aerosols into the atmosphere would not decrease the amount of CO2 in the atmosphere. It would only mediate the effects of increasing CO2 levels. Injection of sulfate aerosols originate from many anthropogenic and natural processes, such as volcanic eruptions, burning of coal, desert dust. The world would experience a cooling effect, which would slow the rate of ice melt and reduce sea level rise. Due to the lack of reduction in CO2 levels, ocean acidification would continue to worsen, and human activities likely would not engage in an effort to reduce CO2 levels. The injection of sulfate aerosols into the atmosphere carries the risk of unknown risk on a global and potentially irreversible scale.
So, what are the benefits of sulfate aerosols? Well, they can create a temporary cooling effect, and they can also reduce and potentially reverse the sea and land ice melt, as well as reversing the sea level rise. Sulfate aerosols can also increase the plant productivity and increase the terrestrial carbon sink.
Some of the drawbacks. There's unknown long-term side effects on human health. There's not a lot of research done on human health. The aerosols slow down the regeneration of the ozone layer. Continued ocean acidification due to the lack of reduction in carbon dioxide. Decreased solar power, and then also they're only effective as long as the aerosols are being pumped in the atmosphere. So it's sort of temporary. It's not a very permanent change.
However, the main drawback of sulfate aerosols is that the atmosphere is a shared resource. So one country does not feel what another country feels per se. For example, while coastal countries can benefit from reduction in sea level rise, inland countries in Asia and Africa are more likely to face potential droughts because of the reduced precipitation. So this solution is challenging because we don't know if it's possible for a country or a group of countries to agree with each other and decide to inject sulfate aerosols into the atmosphere without everyone's approval.
The evolution of the technology. The aerosols would be delivered at least 16 kilometers from the ground, with the ideal height being around 20 kilometers. So many aircraft either cannot reach that altitude or are incapable of carrying large cargoes up that high, making the venture very costly. A 15-year program of sulfate injections would cost roughly 3.5 billion US dollars, with the cheapest current technology capable of achieving the requirements of the project. And yeah, that is it.
Here are citations for both our information and our images. And thank you for the presentation.